Greetings and welcome to Make Programming Fun Again. My name is Karol Moros and today I'm going to show you how to set up a new Golang application using the Echo router, using the PostgreSQL database, Goose for database migrations, and mod to recompile and restart the application. And we're also going to use SQL-C to talk to the database. And this video can be treated as a separate video, but it's also a part of my longer series in which I'm going to rewrite my website called Webauthn Academy in Astro, and I'm going to also rewrite all the tutorials that were originally on this website. At least that's the idea. And I would like to stream all of the work because, well, it could be done in public. And I'm going to call this project that we are going to create today, I think I'm going to call it Diamond Koala because I'm kind of out of ideas. So mkdir diamond koala, and then cd diamond koala, and then I need to ensure that I have Go installed, and I use a tool called Mise. I usually pronounce it Mise. And if you are on macOS or Linux or even FreeBSD, you can use it natively. And if you're on Windows, you're probably going to get a better development experience in WSL2. Anyway, I already have Mise installed in here. So the only thing I need to do is I have to say Mise use Go. And I need to make sure this is the latest Go. Mise upgrade Go. Do we have Go, the latest Go? Okay, so it seems like the latest Go version is 1.25.7. 1.26 has not been released yet as of this recording. And let's see what Mise gave us here. Okay, so it just says Go latest. So we have Go, and now we can use Go mod init github.com/moros/diamond koala. And actually this application setup, it's usually pretty repetitive, but I never use templates because in almost every single project I want to do something in a different way and maybe better than in the previous projects. So I just prefer to set up everything from scratch every single time. And okay, we have a Go module, and now we can probably install Echo. And Echo recently got a new release, so it's a bit different from the previous version. But let's see. Go get -u this. Okay. Go get Echo. And I'm going to quickly write a hello world to see if this is all set up correctly. This is a template that was set up for me by the editor. So the router is going to be echo new, and we have to make sure we are importing from echo v5, and then for get we are going to use a handler called just hello world, and then we're going to listen on port 3000. So router start, was it start? Okay, yes. So we're going to listen on port 3000, and then we can log the error that results from starting if it happens. This is an idiom, so whether you're using HTTP listen and serve or you're using the start method on Echo, this is going to return an error, but it's also going to block the thread. So if it returns, it means the application has failed, and if you stop it in a different way, this log fatal will never get called. So this is a nice way to just this is a nice and concise way to start and log errors if they happen. And then I'm going to just write this handler and it's going to take a pointer to an echo context, and it's going to return an error, unlike net HTTP handlers. And I think we can just write, can you just write response? Can you just write text or something? So this is the raw response writer. I know they also have a JSON thing, but yeah, for now we can just you can just do the regular printf c response, and you just write h1 hello world. So now, okay, and we can return nil, I think so. Okay, so now if I go run, we're already getting logs. We can then go to localhost 3000, and we are getting hello world. We're not getting any logs, but at least we know that we are listening on port 3000. And this is a good first step, so I think this is a good point to set up a Git repository and commit. So I'm going to say git jj git init. I'm not using actual raw Git, I'm using jj, which is a fancy wrapper around Git. Or more specifically, it's a replacement for Git, but it's better. And then I'm going to jj commit -m initial commit, and then I'm going to create a branch. I'm going to call it I'm going to call it main. So jj bookmark set on the previous commit main. Okay, so we have a branch, and now you know, technically we could also create a repository. Gh-repo create diamond koala, and I'm going to make it public, and I'm going to push to this repository. Okay, jj git push -r main, jj bookmark track main remote equals origin. Okay, and now I can push. Okay, great. So now I'm going to set up the project structure. We are going to need a directory for handlers. I usually call them handlers, but you could also call them controllers or whatever. And this is going to contain a file called router.go, and I usually put all my controllers in this directory in one package. I've never really had any issues with it, with this approach. Maybe some purists will sneer at my approach, but I'm not one, so I'm just going to expose the thing we just did in main.go as in here. So yep, I'm going to just expose everything as a function called router. And for now, it's not going to return it's not going to take any arguments. So this is going to take an instance of echo, and you can just return this. And also we can move this hello world function inside this package. And now we can just call the router from here, and the program should still compile. Great. And now what else? So we have this handlers directory, and okay, so in this application, I'm not going to use any views because this is intended to be an API only application. I'm going to also build a front end for it later on. But we have routers. We have a router. We could maybe implement just a simple controller. I'm going to call it health check controller or health controller, and this is just going to always return the same thing. So I define controllers as structs. So this is going to be type health controller, and it's going to be an empty struct. And I'm also going to define an exported constructor. So function health controller, and it returns a pointer to health controller. And then we return an empty struct like this. And then we can define a method on this controller, and I'm going to name the receiver CC because we are going to use the C argument name for the echo context. So this is going to be a pointer to health controller, and yeah, we can call this something like heartbeat, and this is going to take an echo context, and it's going to return an error, and then we just need to return something like yeah, really we just need to return anything, but we can call something like CJSON, and it's going to be port status 200, and then we can return a map, and then this is going to be something like status 200 or something. And then in the router we can just invoke this controller. So health controller equals health controller, and so this health check endpoint would just call the heartbeat action of this controller, and if we make a request to this controller, we're going to get HTTP localhost port 3000 health check. Wait, what? Okay, so we are getting a method not allowed because we are making, by calling -i, I'm actually making a head request, and the echo does not really understand it. So I think I would need to call, I think there are helpers in echo to do it, to a middleware method override. Okay, yeah, this won't help because this is only intended to help us with post requests. So in the browser, if you are making a request using just an HTML form, then you cannot override the method. You can only make it a get or a post request. So a common workaround is to use a hidden field call method. But this doesn't help in our case because we actually want to handle head requests. So maybe, yeah, I'm just going to make a request, a regular GET request instead. So we got and HTTP 200 OK with the content type of application JSON, and we got a valid JSON object, which means this is working. And I think at this point we can start setting up migrations. So for migrations we are going to need a directory. I always put my migrations in DB migrations, and I think this is a habit from Rails. I'm going to add a .keep file, so even if this directory is empty, Git will remember to create this directory for us. And we're going to need to install the Goose CLI. So this is where Mise is going to become very useful, because we can just call Mise use go colon and like this, and then I'm just going to make sure this is really the latest version, because it's definitely cached on my machine, but yes, it's the latest version. So now if I call Goose, we can access the Goose CLI, and we can also see where it is actually installed. So this is installed from Mise. So this is all we had to do to install Goose. And this is obviously much simpler than the approach I used in the last video, which was using the tools go file. Okay, and now we are going to need to set up environment variables, and we can also do this through Mise. I think we just need to define a section called env, and then we can say goose driver equals Postgres, and I'm going to reload and see what's goose driver. Okay, echo goose driver, it's set to Postgres. Okay, this is correct, and then we can export. We can also set up a database name. I'm going to use the variable pg database, and I'm going to call the database diamond koala development or dev, and then we can set a database URL as Postgres user Postgres, password Postgres at localhost port 5432, and then I'm going to interpolate this pg database variable, and then I'm also going to add SSL mode equals disable, but I'm pretty sure at this point SSL mode I'm pretty sure at this point the Postgres driver should be able to also handle connections over TLS. Let's see, PSQL database URL. Okay, the database does not exist. We can create it using just create DB, and then we can connect to the database. Oh, and by the way, I have PostgreSQL installed using Homebrew, and installing Postgres is probably beyond the scope of this video. Okay, we have database URL. Now we can set goose db string equals and the database URL, and then goose migration directory equals db migrations, like so. So now I can generate a new migration by calling goose create, and we're probably going to start with a users table. So I'm going to call my migration create users, and it's just going to be a SQL database, a SQL file. So now when I go to this file, I can just define my migration. And I'm going to use an extension called CI-text, which stands for case insensitive text. So we need to call create extension CI-text. We can also say create extension if not exists, and then create table users. And then I'm going to define the primary key as a UID v7 column. So UID not null primary key default UID v7. And this is so this UID v7 function is a new addition to PostgreSQL 18. And then we are going to store the email address, which is going to be CI-text not null unique. And then we're going to store the password hash, which is going to be text, and it can be null. And then we are going to store inserted at, which is the time of the creation, and it's going to be timestamp. It doesn't matter if we call it timestamp without time zone or timestamp with time zone, because the SQL standard does not actually store time zones. So I'm just going to call it timestamp, and I think by default it has like nanosecond precision, which is probably overkill, but it doesn't really matter. And it's going to be not null, default now, and then updated at timestamp not null, default now. And I think we also need to make sure that the database is set to UTC. So PostgreSQL set time zone. For database. Well, okay, we can actually, if we can believe this, we can actually set the time zone for the whole database using this command. So I'm also going to say alter database. What was it? I think our database was called Diamond Koala Dev set time zone to UTC. And this way, if we call now, it's going to be UTC by default, and really in the database we can just default to UTC because it's going to save us a lot of conversions. And then this is the part that creates the table, and then this is the down part, which is going to be called if we ever call goose down, and this is going to drop the table users like so. So let's see, if I call select now, if I call select now at this point, in this database we're getting a local timestamp, which is in the UTC +8 time zone, which is correct because I'm in Taiwan. And now if I call goose up, what time am I going to get? So now I called now that I called select now, I'm getting a UTC timestamp, which is the desired outcome. Okay. So now we know that goose up works. Let's see if goose down works. So now, do we have any? We still have a table called goosedb version. We just don't really have any. We don't have the users table anymore. So I'm going to rerun the migration and see. But now we have a table called users, and it does indeed have a UID column for ID, and a CITEX column for email, and a password hash column, a text column for password hash. So right now everything seems to be correct, and we can probably commit. So jj commit set up goose migrations. And now we can go ahead and probably do and set up SQL-C. And in order to use SQL-C, we're going to need to install SQL-C. So just like before, we can just install it using mise. So mise use go like this. And since I have already installed this command before, it just works. And I'm going to quickly check if I'm using the latest version, which seems to be the case. It's 1.30. And I'm going to also need to create a SQL-C file. So we can do it in the DB. I think I usually create it in the root directory of the project. So it's going to be called SQL-C YAML. And yeah, it should be in the root directory. And then we're going to write this file by hand. So firstly, we want to define a version. So version is supposed to be it's always supposed to be 2, and then we're going to define the engine as PostgreSQL, and then queries, it's going to be DB. I think I usually store those at DB SQL, and the schema is going to be DB migrations, and then in the generator, this is going to be in a package. What was the package again? Yeah, queries, and then it's going to be outputted at DB queries, I think. And then the SQL package, we could use the libpq package, like the default. We could just use a default driver for PostgreSQL, but if I'm not mistaken, the one they suggest, PGX5, it is a bit more performant than the regular PostgreSQL driver, and it's also multi-threaded. I mean, it has pooling support. Let's see. Code gen. Okay, so the database. No, okay. A SQL package. It defaults to the database SQL, but we're going to use PGX5. And then we are okay. Emit results, struct pointers, yes. This is something we want to use. And then SQL package is going to be this. Yeah, SQL package is going to be pgx5, like this. So let me see if this is going to work like this. If I create a directory called SQL and I'm query the users in there, for example, let's just say I'm going to write a query called get user by email, and it's going to return 1 or 0 results, and I'm going to say select asterisk from users where email equals 1, and then when I call SQL C generate, okay, field package not found in type, so SQL package not found in config SQL again. Okay, I think this is because I have to put this inside of a Go section. So now it should have generated queries, right? So let's see. It generated a model called user, and I'm not exactly sure if I want this password hash to be a PG type text, because this seems like a wrapper. I prefer to just use emit pointers for null types, like this. So true. So now it's just a pointer to a string, which is what I wanted. And then this is a timestamp which is correct. I could probably also just instruct it to use a time.timestruct. So okay, I'm going to define an override. So db type pg catalog timestamp. And you may also notice that email is defined as CI text, but SQL C is already smart enough to just convert it to a string. Nullable false engine. Okay, engine doesn't matter. Go type this import time, and then package time, and then type time. So now this is, wait, what? Okay, I probably don't need to import it like this. What about like this? Okay, so now this seems to work as expected. We have an import of the standard library time package, and then the inserted at timestamp is being converted to a time.time, and then this PG type is converted to a UUID, a PG type UUID thing. And then what else do we have here? This is what SQL C generated from our queries. You may notice that the asterisk was expanded into all of these. So it has an, instead of just outputting the asterisk, it actually checked the database schema at generation type and made sure this is going to be type safe, which I think is a great feature. And then you may see that this also just calls This also just calls the query row function, and then it just scans it, which is very well optimized. It does not rely on runtime. It does not rely on runtime reflection. And now we can also see that the LSP is complaining about not having access to this PGX library, so we need to run go mod tidy. And now it should stop complaining. And we could, at this point, we could probably define a new controller. I think I could just call it users controller or user controller. And then we can just return some data from the database. So package handlers, type user controller struct, and then this is going to have, this one is actually going to have access to the DB connection. And since we could also make a second degree of indirection, we could also define services, but for now I'm just going to call the database directly from here, and we are going to work on this project later in the future, and then we are going to also get services. So for now I'm just going to define a field called DB, and this is going to be a queries dbtx. And this dbtx is an interface that was defined by SQL-C, and it basically just matches a PG connection or a Postgres connection pool. And then we can define a constructor, a quote-unquote constructor, user controller. This is going to take a dbtx, and it returns a user controller, and this is just going to be a wrapper, like so. And then you know what, we could also just return, we might as well just return a list of all users, right? The name list users, and this is going to return many entries, and then just select asterisk from users, order by email, like this. Okay, and this is going to be an action. I'm just going to call it index. It's going to take an context, and it's going to return an error. So we can go straight ahead and just call users error equals ccdb, and you know what, we can just directly query the DB. We need to initialize queries, and we also need to run SQL-C generate. So now we can call queries new list users, and this is going to be take the request context. So now it's complaining because it doesn't know that the users function exists, but I can already see that it exists. And then yeah, and this has to be a function call. So if error equals nil, return error, and otherwise we can return CJSON, and then 200, and then usually I would do something like yeah, let's do it like this: map string any, and then it's going to be data users, and let's see what this returns. So go run. Okay, and at this point we are not calling this anywhere, so this is not going to work. We are going to need to actually pass the connection to the router. So we're going to pass the queries dbtx, and you're going to instantiate a controller. So user controller with a database connection, and then API v1 users index, like so. And before we can connect to the database, we're also going to need a helper to help us get the database connection string from the environment. So I always use this helper function. I'm calling it mask.env. It takes the name of the environment variable and returns a string. It is guaranteed to return a string. Value equals os getenv name. If value is empty, log fatal f, fatal environment variable is not set, and then return the value. And then we can define a connection string. A database URL equals mask.env database URL. So now if I run, okay, in main.go, I'm going to connect to the database. So database error equals pgx pool new context background, and then config database URL. If error is not nil, log fatal error, and then we can pass this connection to the router. And now, why go mod tidy? Okay, go run. So now, if we curl http localhost port 3000 API v1 users, we are getting this is giving us a null and this is technically not incorrect, but the reason let me see. Yeah, I could probably just define an ad hoc structure, and maybe this then it would return the actual thing. So struct data, and this is going to be a list of pointers, the user, like so, and then it's going to be like so, defined like so, and maybe then it's going to be serialized the way I wanted, right? Okay, so now it's still returned as a null, but it's even worse because now we are also getting uppercase capitalized struct names, field names. And okay, it's still null. So if we go to go dev and then go to the standard library and then go to encoding JSON. Wait, we have a v2. Okay, this only exists when building with an experimental flag, so I'm going to use a regular JSON thing. And then we need to look for to just ask GPT in Go how to serialize empty slices as JSON array. Okay, so no help here. Maybe if users equals nil, users equals you know, like an empty array instead of just nil. So now this works, but this is obviously a very bad workaround. I'm pretty sure Echo may have something to say about it. So JSON okay, I think I may need to figure something out. It's irrelevant really. But if we go to user SQL Go, we can see that this defines an empty. This syntax defines an empty a nil array, a nil slice. So maybe there is some way to initialize it. Okay, what does emit empty slices say? Okay, so if we just call emit empty slices, if we define emit empty slices in SQL YAML, then this should be unnecessary. Okay, no, we have it called a SQL generate. And now we are getting an empty slice instead of nil, which is great. And if we see at the generated code, we can also see that the way this slice is instantiated now is using a literal instead of just defining a variable, which is the change we wanted. Okay, so now that we have a controller, maybe the last thing I'm going to cover is setting up a mod. And obviously the way we're going to install it is using Misa use Go like this. And the latest version is 0.8, which was released almost 7 years ago, over 7 years ago, but it still works. So I'm not going to complain. I'm also going to define a gitignore file, and I'm just going to ignore the server file because I'm going to use it as the name of the compiled artifact. I'm going to define a mod.conf function. So for every Go file that is not a test file, I'm going to prep Go build -o server, and then daemon plus sigterm server, Let's see if this works. Mod. Okay, this has correctly compiled and started the server, and then we can also see that this server is an executable. And also in the router I would also set up some middleware, so you can call me, say, use middleware. No, and I don't want chi middleware, I want real IP. So what package does this come from? No, I don't want chi middleware. I want a logger. So this is going to be request logger. No. Okay, so now this actually worked, I think. And I may still need to run go mod tidy. Okay, so now we have this request logger middleware. We have use middleware. What else do we have? We have a request ID. Maybe we want to generate request IDs, and maybe we want to does this handle forwarded forwarded for? Does it have CSRF protection? What does CSRF protection? Okay, yeah, this looks like a good choice for some basic middleware. So now if I call the API using curl, we can see that we get this gets mentioned in the logs with a request ID. Okay, great. We could actually talk a bit more about this project, but I think I'm going to call it a day. And I'm going to talk about this project more in the next video, which is hopefully going to happen tomorrow. So if you learned something, consider liking and subscribing, and if you didn't, please let me know in the comments. And I will see you in the next video. Goodbye.